Hello, I'm Gerald Mobbin. I'm an instructor here at Jackson County ATC where I teach carpentry technology. Today we're going to learn how to step off a rafter using the step method. I have found it to be very accurate. We're going to be using... There are lots of different styles of roof and rafter configurations in construction. The most common and used widely is the shed roof, which is used for most outbuildings whenever maybe you want to save on materials or use your materials a little more wisely. The most common in construction as it concerns homes and residential construction is the gable roof, and also of course is the hip. And we have several varieties. Those three roof styles can be found on any particular one home in many times. So the combination of the hip, the gable, and the shed. Now here we have a combination of just gable and gable, an L-shaped roof, gable roof. Here we have a hip roof with just hips on each end, and here we have a combination of the common gable and the hip used together. Now on a story-and-a-half house, perhaps there would be a shed roof on this back side as one long dormer. Now in roof construction, what we are actually doing is we are forming the diagonal of a right triangle, as you can see here in the mathematical equation by Pythagoras, that first, if we know what side A and the base is, then we do A squared plus B squared, which gives us the hypotenuse of the diagonal. Rafter construction is always on the hypotenuse of a right angle, and here it shows half of it, as you can see that it is indeed two halves. Now in rafter construction and cutout, there are certain words that are used that entail what exactly is involved in the entire roof system. From outside wall to outside wall is your total span, and from the center or the A side of a right triangle we have our altitude or our rise, our total rise, and that would be all the way from under the ridge pole or the ridge beam to the top plate. Then we have the total run at the base, which follows along that top plate to the outside wall, and thus from that bird's mouth there all the way up to the ridge pole would be the hypotenuse or the diagonal length of a rafter. Now a rafter has several different parts, and I want to show you on a piece of dimensional lumber those parts. The common frame and square. Of course, I want to remind you that this is the body and this is the tongue. We will be getting our rise from the tongue portion and our run feet in the body. Now in every rafter demonstration, I'm going to be going rather quickly through the common carpenter's frame and square. Some people call it the steel square, and I have three here, one with stair gauges, one without. These two are aluminum, and I have one here that is aluminum square that's been painted black, so all of these details and numbers in this Essex board can be read easily. As you can see, there's quite a contrast if I move those two together between the rafters. This is easier to read, and I prefer a square that is easy to read, but nevertheless this black square will take on a lot of heat out in the sun, and so you must keep your square, if it's painted in, for example like this one is, in the shade. You must put it in a shady place, because as you handle it, the sun will heat this up and make it very, very hot. Here we have an Empire Speed Square. Of course, Speed Square is a brand, and on this square is all of your hip and valley cuts, and here all of your common cuts. all the way from a 1 in 12 slope, a 2 in 12, a 3 in 12, and what we're going to be using today, a 4 in 12 slope. The bottom side is our compass, all the way from 0 to 5, and it's broken down in 5-degree increments all the way through until it reaches, as you can see, 75, 80, 85, and of course 90. Up here is simply a rule for inches as you're laying out a square. Now this square is quite adequate and very handy, and it's faster than the common carpenter's framing square, and we'll discuss that later. I just want you to see the tool and to be able to identify the parts. Here we have all of the same information as on the other side. What we are creating, we're creating the hypotenuse of a right angle. So to technically lay out a common rafter, we first have to have a span. The total span would be the total with the building. The run feet would be the portion to halfway. Now I have set up a small example here, and I have one common rafter already installed. This, of course, is our ridge beam or a ridge pole. It must be one dimensional width larger than our rafter in order to gain full support along this area. So today I'm going to be demonstrating how to lay this common rafter off on this small example. I have used some star gauges, and star gauges are nothing more than little clamps that attach to the square, allowing you to gain better control and more accuracy. And I always have a couple of pairs of these star gauges available always for this type of detail. I've already set up my star gauge so that I have 4 inches of rise, which is here at 4, and that 4 must be at the corner of the framing member. On the other side, I have adjusted my star gauge so that my 12, which is my run inches per foot, is on the edge. Now, our example here is half of the total span, which would be equivalent to an 8-foot wide building. So we're going to step half that distance, which would be 4 steps. Having our square laying on our member, we first need to have the member crowned. And the crown is the arch or the bowl that would be in this area. That bowl in that material must always be up. So I have pre-examined this. The crown, of course, is up. If you become a little confused, a simple V-shaped mark showing you where the crown is at is sufficient to keep that in mind. So we're going to step 4 times down this total run. So I'm going to make a mark along this, which is called the face cut. I'm going to make a mark then on my run feet at 12 because we have a 4 in 12 slope. I'm going to move my square down to the outside of my tongue, right at the corner, so my mark and the 4 line up. I'm going to mark again. Now, some people like to count these as they go, so we'll do that. We'll just count it. This is 1 step. I'm going to make another mark at the 12. I'm going to slide my square down to that mark. I'm going to mark it again. This is twice. So, with my mark again at 12 inches, I'm going to slide my square down to that mark, bringing the 4, my 4 in 12 slope. I'm going to mark again. This is 3. Again at the 12. Now we have become 4 times that run for a 4 in 12 slope. Now at this point, at that step there, we must create what's called the bird's mouth. Now there are several features to a bird's mouth, and it is typical that the total rise of a bird's mouth when we install it can only be no more than 1/3 the total width of the frame and member. And this is how I arrive at that. I simply take my rule, and on a 2x6 I will just use 6, and I will slide it across at this point, and I'll simply go up 2 inches, which is 1/3 of the 2x6. And remember, I'm using the total span of 3 inches, which will break this down quickly, and it's very simple math. So at 1/3 of the total would be, of course, 2 inches. I'm going to make a V-shaped mark right there. Okay, with that made, so that I know, I'm going to put my square back on. I'm going to mark at that 2-inch location, which is 1/3 of the total width of the frame and member. Now, I have here, at this point, created the seat cut. And this is heel or the plumb cut. Lots of people call it lots of different things. I've always referred to it as the heel. We'll call it the plumb cut. This total member here that I am taking out of this is called the bird's mouth. That's what we're going to remove. Now, before I cut that out, while I still have my framing member here, I'm going to lay out for my tail cut, which is actually going to be 16 inches overall. Now, this is very important along this cut because we can use the inside of our square to do all of the math for us. At a total of 16 inches, we need to allow room for the gutter board or the barge rafter, if you will. So we're going to deduct out of 16, 1.5 inches, and we're going to make us a mark there. And we're going to again slide it down, our square down, and there we have marked our tail cut. Now it's very important that all of this be laid out correctly. Now, if you'll take a look right here, I have made a plumb mark down the center of my ridge pole. That is 3/4 of an inch to either side. Now, in the step method and in any other method that you might approach laying out a rafter, we must deduct 3/4 from this total length of this rafter because every method assumes that these rafters will meet in the center. So we're going to deduct from our rafter 3/4 of an inch. We'll do that right now, and I'll show you how. Okay, at this point, there's a variety of ways of doing this. We can measure back with our tape and measure back 3/4 and make a mark, or I prefer to just simply use my square. It gives me something to actually hold against. So I'm going to measure back 3/4 of an inch, and there we have it. That is 1/2 of my ridge member. This will be, in actuality, the cut line. This line I just simply mark through it so I know not to cut on that line. Now, I'm going to proceed to cut this rafter out. It's very important that we keep in mind all of the safety protocol in managing a tool. Now, as we cut this bird's mouth out, since our circular saw is cutting with a round blade, we can make these marks intersect here, but you'll notice that at the back of the rafter, we still do not have that cut through. So we're going to use a typical hand saw to cut that out. Pause it right there. Now, I'm going to just take my I'm just going to take my handsaw and just follow the path of the saw that's already been created. And our bird's mouth is complete. Now I'll proceed to make my tail cut, and we will install this rafter. With our rafter properly cut, generally, and I have installed here just some little short typical ceiling joist patterns with this slope, which is a 4 and 12 slope. And our rafter. We have now installed a 4 and 12 slope rafter using the stemp method. This is very simply done, and once you've observed doing it, it becomes much easier for the average student or even layman to make a set of rafters for any building, as long as those common rafters follow this simple plan. Thank you very much.